All right, let's kick off. Hello, everybody. This is going to be a really interesting and hopefully intersecting two-part talk here at PancakesCon about using Jupyter notebooks in information security contexts, as well as using elbows in your self-defense arsenal, and since we're all self-isolating, to also increase your physical fitness in a small amount of space. Let's get going. So up first, I want to tell you a little bit about myself, just so we're all acquainted. My name is mttaggart, as Corinne said. Most of my career was spent in K-12 education as a tech director and computer science instructor. And about 2 years ago, I made the switch over to InfoSec, and this is actually my first con talk, so I'm really, really excited to be here. I am now a security analyst, and I work in the healthcare sector. I am a self-taught programmer. I'm a self-taught everything IT. I started life as an English major, but I think a lot of us took kind of circuitous routes into InfoSec. It's kind of why I love it here. And I've been a lifelong martial artist, and we'll talk a little bit more about what I've done in the martial arts when we get to that section. I love aviation. I love Star Trek. You know, your general kind of nerd. Since arriving in InfoSec, I really feel like I've found my tribe. In fact, I need to take a second before I go any further to specifically thank Leslie Carhart. She doesn't know I'm doing this, but it was her generous gift of a ticket to Hope in New York in 2018 that actually inspired my passion for InfoSec and convinced me to pivot my career in this direction. And so in many, many ways, I would not be here giving this talk if not for Leslie. So some context before we get started. Um, I'm glad that this talk is actually coming after Jared's talk, talking about computer programming. In order to use Jupyter, because it's built on Python and other programming languages, it does require a little bit of computer programming experience to really understand what's going on. So these two talks are related. What Jupyter, broadly speaking, is an interface for literate programming. And what that means is that there is written text that is meant for human consumption interspersed with executable code. And we'll see more of what that looks like when we jump into the Jupyter notebooks. But I want to take a second to talk about literate programming itself and what that means. Donald Knuth, who wrote the book, he literally wrote the book, The Art of Computer Programming, talked about literate programming. And what he meant, he wrote this in the 90s, way after he did the first version, the first edition of The Art of Computer Programming. What he meant by literate programming is that the bulk of a computer program should actually be intended not for machine consumption, but for human consumption. And so if you think about it almost like a logical proof or a philosophical essay, most of the body of the program is actually supposed to be for humans, and you're explaining the rationale for what you're doing. And then interspersed with that, you would actually have the machine code for what we're trying to accomplish with the program. Jupyter makes this really accessible as a concept and puts it into practice. Jupyter's found a really, really comfortable niche inside of machine learning and AI, as well as data science writ large, sociology, epidemiology, kind of topical. And let me throw up my webcam right quick. There we go. Here I am. Okay, so all right. Hopefully everybody can still see what's going on.
Fine.
Okay, cool. So Jupyter started as IPython, and it was built originally in Python, but it doesn't have to be based in Python. Jupyter now supports multiple kernels. So if you're familiar with Node.js, you can use Node. If you're familiar with Haskell, you can use Haskell. If you're familiar with Scheme, you can use Scheme. I think there's a C# kernel as well. So really, if you have a pet programming language that you like, it's definitely available. Oh, interesting. Slides aren't changing. Well, in that case, let's see if we can switch over to a different window.
Hey, if your slides aren't changing, the best thing to do is stop sharing and then start sharing again, and then it should take off.
Okay, I just did, and let's see if that helped for folks.
Are they actually progressing on your system, or are they not even progressing on your system?
No, they are definitely progressing on my system.
Okay, so just take us out of presenter mode and just be like in the standard mode, and we'll just go through that way. It's probably the best just to get through.
Looks like folks are seeing it now.
Okay, there you go.
All right, cool. Sorry about that, everybody. Okay, cool. So let me know again if it doesn't change. I am keeping an eye on Slack just to see. All right, so why do I think Jupyter is really important for InfoSec other than my own personal experience? One of the things that Jupyter does for us as a team, a security team, a DFIR team, whatever we are, is that it can unify our procedures around a single skill set, which is Python. Sometimes you need a sim and sometimes you don't. And what I mean by that is that we have a lot of data coming in ideally, and processing it and analyzing it is often the job of these enterprise applications. Our organization may have it, our organization may not. But with Jupyter as an open source tool, we have the ability to do serious data analysis without the overhead of a full sim if we can't afford it, or if for whatever reason the data isn't going into a sim. I know that never happens, right? All of our endpoints are reporting to our sims, right? But if there is a situation where they aren't, and we do have access to the logs another way, we can use this tool to analyze the data so that we can do threat analysis and identification. And a lot of my day-to-day is about threat hunting and also security analysis. But if Python can do it, Jupyter can do it. And so why that's really valuable is your application that you write in a Jupyter notebook is self-documenting. And I don't just mean because of code comments. I mean that because you can intersperse text, which is formatted in Markdown, along with your executable code, your runbook can actually run. And so your whole library of procedures can be stored in Jupyter notebooks and executed by members of the team who all have this same shared skill set. All right. So hopefully I've sold you on the potential value of Jupyter. How do we get started? Because it's based in Python, you want to make sure that on your system, Python 3.6 or above is installed with the pip package manager. You can go to python.org to grab it if you don't have it on your system. And then you're going to use pip to install Jupyter Lab. And then you open the interface in the browser. I've also put together a Git repository with some starter information and the two notebooks that we're going to be talking about in this presentation. So if you want to go ahead and grab that, feel free to follow along. We'll start with some Jupyter basics and go through what a notebook looks like. I'm going to exit out of my presentation here and switch over to a different window. Hopefully you guys can see this as it comes up. All right. Folks, are we seeing the browser view? Great. That's what we need. My Python sure is actually out of view, but there we go. Thanks, Emily. So this is the link for our Git repository if you want to follow along. And I should point out that I am using in our demonstration today some of the data from the Splunk tutorial data. So what we're doing with data that otherwise Splunk would be using, but we can do it with this as well. All right, so I'm going to hop over to Jupyter Lab here. I have Jupyter Lab running in my browser. This is what happens after we run Jupyter Lab in the folder that we want to fire up the lab environment. And this is the interface that we get. Just taking a quick tour around, what do we have? Well, we have a file browser on the left, and then we'll get a launcher window right here, and we can start different notebooks with different kernels. Now, I only have the Python 3 kernel installed, but if you have other kernels installed like Scheme or Haskell or Node.js or whatever, PowerShell, you'll see them here. So you'll be able to launch notebooks with different kernels right from this interface. You can see also that it has a built-in shell. You can do a text editor, markdown file, whatever else you need. So it's a really nice all-in-one environment. Let's take a look at our first intro notebook here. So the most important concept in Jupyter Notebooks is that our document is separated into cells. A cell is a section of text or code. By double-clicking on this first cell, you can see that this is formatted into Markdown, right? And anything you can do in Markdown, you can do here. When I run the selected cell by either clicking the play button or typing Control-Enter, it executes the cell. Now, executing a Markdown cell means formatting it, right, and showing the resulting HTML. Executing a Python cell will execute the code. So if we run this one, we'll get the output right here. Another really, really cool capability of Jupyter, which is actually above and beyond what even Python can do easily, is interaction with the shell. So right here, I'm using the exclamation point macro and then using an ls command with the ww1 folder. And I'm assigning the result of that to the files variable. So on the left-hand side of the exclamation point, that is that's Python. And then on the right-hand side, that's Bash. So if I run this, you'll see that I get the contents of that file, of that folder inside of a list. The other thing we can do that's really, really helpful inside of Jupyter is we can use the input command inside of Python to ask for data from the user. People are asking to zoom in, so I shall. Hopefully that helps. So with input, we have the ability to get information during runtime. Right, we'll zoom in a little bit more. Make sure everybody can read it. So what we have here is the ability to get input during runtime. Why that matters is, let's say that you're interacting with an API or you're interacting with some sort of sensitive process. You don't want to store secrets in the Jupyter Notebook, right? Even if it's a private repository or anything. So what you can do is ask for those credentials at runtime and then run your notebook as necessary. So let's run this cell and just see what happens. I'm going to put in my name. So a couple of things are going to happen here. The first is I'm getting the input, I'm getting my name, and then I'm assigning the result to a string that is my name inside of the hello world string, right? And I'm doing this a little bit different than Jared showed. I'm using the format method inside of Python, which just inserts the name here inside of these curlies. Now I'm printing to the notebook itself, but notice the other thing I'm doing. I'm using the exclamation point, so I'm using shell commands right from here, and then I'm sending it, right, with the output redirection to message.txt. And if you were watching carefully, you'll notice that over on the left-hand side, I have a new file in my folder, right? I have message.txt, which I can just open here. So if I need to save output from commands, I can send them from Python to the shell with basic Unix shell commands. And vice versa, if I am able to format text, let's say I'm using cut or set or awk or something to take a text file and reformat it in a saner way, I can get that information directly into Python without having to do, input file streaming or anything like that. I can just get it assigned to a variable using that exclamation point macro. Right. So the next notebook I'm going to show you is admittedly a lot, okay? Because of the compressed time, I thought it was valuable to go through kind of a real world application of this, but it's going to be a lot. So I encourage you, if you're really interested in this, to dive in and see what we're doing. But what we're going to do in the next notebook is go through log analysis with Jupyter. And the logs we're going to be reviewing are the logs from the Splunk tutorial data. So this is real stuff that Splunk otherwise would be using, but we can use Jupyter to do it for free. Okay, so there are a couple of libraries, just like Jared was talking about earlier. We use external libraries to augment our capabilities inside of a programming language. We are using Pandas, which right here is a very, very popular data science library for Python. Pandas, big takeaway for Pandas is that it allows us to create tabular data objects called data frames, kind of like spreadsheets, but with a little bit more juice, that we can use for data analysis. And these data frame objects have a lot of built-in analysis tools and even visualization tools. So if we can get our data into a tabular form, get it into a Pandas data frame, we're golden. We're also using the venerable matplotlib, which is kind of the open source version of MATLAB, if any of you had to use MATLAB in school, to do some of our plotting. Now, Pandas uses pyplot, part of matplotlib anyway, but sometimes you want to just use it by itself for more customization of your graphs. And then another library I really like is Seaborn, and Seaborn is just a very, very ergonomic data visualization tool. So if we take a look here at the gallery, you can see that there's kind of an amazing amount that you can do with Seaborn, just with tabular data. And it's actually designed to work with Pandas. So definitely recommend checking these out. So what we're doing in this notebook is we're looking at the access log from a web server, and we're also looking at the security log from the server and seeing what's going on between the two. Now, because I don't know if any of you have ever looked at access logs, but let's look at one right now, right? You can see here, I'm taking the first entry from both the access log and the secure log, just raw. And it's just text, right? It's unstructured and they're not even the same. So we have to do a little bit of legwork to break this down into tabular data. Now, some of you command line ninjas out there can probably use cut and set and awk to just like turn this into a CSV right away. Totally, you can do that. I have found that often it's easier for me to use regular expressions when possible. I know that that can be a little bit tricky, to build up the data frame piece by piece. Some folks in the chat are talking about Bro and Zeke. And it's very funny because I was actually attending the security onion training with Zeke last week at WWHF, and this is a great tool to augment all of that stuff. And it doesn't necessarily replace it because, and especially Rita that John was talking about earlier, right? This can do some of the same statistical analysis, but again, I would recommend using it to augment some of these other tools. But what we're doing here is we're building up the data frame piece by piece, right? And you can see that just by getting the raw data into a column called raw, we get a shape for each one. And this is number of rows and number of columns. So you can see that our access log has 13,000 some entries, our secure log has 10,000 some entries. So they're not quite the same length, and we don't know that they're related yet, right? We still have a lot more work to do, but we do know that we have a bunch of data, which is good because the more data means that if we do statistical analysis, we're more confident in our results. The head method will take just the first 5 rows and show you what you're looking at. And you can see that we're indexed by integer, and then this is just the raw text with the column name of raw. If I want to break this down, I can use the bracket method to access specific columns of a data frame, which is what you're seeing here. But I need to make more columns. I need to turn this into IP addresses and users and timestamps and all of this stuff. So how do I do that? Well, in this case, we took a look at what was common across the log entries and how they were structured. And for the IP address, right, what we did was we're creating a new column on the access log data frame and the secure log data frame. And we're just using the built-in .str methods in pandas to extract things that match a regular expression. Regular expression gurus out there, it's the capture group that we're after right here. So anything that's caught in that capture group is what's going to be added to the new column. And now you can see in our data frame at this point, now we have an IP column that matches what we want. What's cool about this is now that we can do counts by IP, right? We can do pie charts, all sorts of stuff. For timestamps, similar process, right? We have to be pretty careful with our string, but for the access log with secure, we don't, because the timestamp is right up at the front always. And because of the way they formatted it, it's of regular length. So we can just take the first 25, characters. And now we have our timestamps. Here are a few other examples of columns we can make using the same sort of approach. Again, these are a lot, so I recommend if you're interested in this, go ahead and check them out. And if you find any mistakes, please let me know. I definitely don't claim to have this 100% down, but it's been working for me so far. I want to take a quick second to talk about indices. This is a special idea in pandas, which is the way that the data is sorted and how you access rows. By default, when you make a new data frame, indices are just integers, right? Row 0, row 1, row 2. But you can make indices out of other columns or other kinds of data. And the most valuable usually is what we call a date-time index. And that comes from taking that raw string of the timestamp and turning it into a date-time object, and then setting that the series of date-time objects as your index. Luckily, Pandas has a built-in toDateTime method that allows us to take the timestamp, and if it is sanely formatted as the security log ones are, we can just infer the objects, which turns it into a string, and then pass that to datetime, and now we have a timestamp. If they're a little bit wonkier, the way that the timestamps are in the access log, we can give it a format string to tell it exactly how to extract the data information. After that, we have ourselves a datetime index, which allows us to arrange things by time. Why does that matter? Well, if we want to view things chronologically, imagine the number of events per second, right? Imagine that we are concerned about a DDoS attack or a brute force, right? We're going to see a jump by time. And now we can analyze that visually as well as in a tabular method because we have the date time index. So sure enough, as we go through the data analysis and we group by minutes, you can see that here, our security, everything happened in 1 minute, or at least 1 minute number. Whereas our access logs, right, we see a lot more minute counts, right? Things happen at minute 0, minute 1, minute 2. Now this isn't as clear as we'd like it to be. And for that reason, we often want to group by multiple things like hour, minute, by hour and minute, right? And second. So you can see this happened all at midnight at different seconds. This happened at 11 o'clock. But this is a really good example of where tabular data might fail you, and you might want to consider visual analysis. So with visual analysis, right, we can get those counts, the same thing that we saw above, and using the built-in plot methods, we can get ourselves access events per hour. Now we grouped by hour for this kind of resolution. And you can see that we actually started right at midnight, that there was a massive amount, and then we kind of jumped down. So we'd be really curious to see what was going on up here at the high point. A good question from the chat is, if time is your indices, then what happens when multiple events happen in the same second? So what we're doing is we're aggregating them, and so by count. So what we can do is if we group by hour, right, you can see how many happened per hour. If you group by minute, you can also just plot across a full time index, and Pandas is smart enough to kind of put those things where they belong. So you can do this a bunch of different ways depending on how you want to look at your data. But creating a date time index just means that you have the actual time of the event available as a way to reference the data. Security was a little bit interesting because we found out that all of them happened at the same second. It was kind of wild. And if we broke it down even further, it all happened like at midnight +2. So something was going on there. I know I'm running a little bit short on time for this section, so I want to quickly show you that we have another couple of ways to show things, like a pie chart. What I've done here is I've taken the top access IPs, so I've grouped my access data by IP, grabbed the count, which turns it into a new data frame. I've sorted it by the raw, just to show the IP address, and then the ascending is false. What that means is I'm getting the top 5 IPs by count. And well, head gives me the top 5. And then I'm plotting those with a pie chart. So check it out. I now see the share of the damage done by my top 5 IPs, or the top 5 access attempts by my top 5 IPs. So what could I do from here? I could throw these against threat intelligence, right? See if any of these are IOCs. I could throw these against my CMDB to see if these are things that I know about, right? And I can script all of this out in my notebook as part of a standard procedure that my team executes, so that I don't miss anything in the procedure, right? The programmatic stuff is automated because it's happening in the code, and then the human stuff is happening because I'm running the documentation as a member of the team using this standardized practice. Same thing here for failed user accounts. I love this one. So we pulled out anything that had a failure report in the security log, and then we grouped it by users, and then we did the top ones, and then we found this chart where we see who are the top user failed logins, right? That's a lot of admin, that's a lot of administrator. This smells fishy to me, that smells like brute force. I might be looking at the IPs these are coming from next. I might be looking at successful logins to see if there was anything else going on there at the same time. So it's a really great way of doing a little bit of threat hunting here. And then, as I said, we can expand this by tying into external APIs. You could tie into VirusTotal, Talos, other threat intel, or any other tools that expose APIs in your organization. All right. Quick final thoughts on Jupyter. Let me just confirm from the chat, guys, that you can still see my screen. Cool. How about now? Rad. Okay. So final thoughts on Jupyter. As I've said, it's a really powerful platform for any area of InfoSec, as long as the skill set is around in your team to use Python. That can be a big ask depending on your team, but I think that the ROI is pretty solid here. And again, because you can standardize documentation and the actual procedure inside of the same document, the potential for creating an institutional memory of known and executed procedures is really powerful. So organizational value. All right, got about 16 minutes or so to talk about elbow strikes. So I'm going to pivot over to elbow room. So I'm a lifelong martial artist, and I started my martial arts career in traditional Chinese martial arts, Northern Kung Fu, Tian Shan Pai, and then moved into some internal arts like Xing Yi Chun and Tai Chi Chun. I know I'm butchering those pronunciations, I apologize. Kind of a strange Northern art called Baji Chun, which is, Baji is actually 8 extremes. And so much like Muay Thai, which is often called the science of 8 limbs, it was a style that was about using not just your hands and your feet, but also the middling joints, right? The elbows and the knees. And I moved into Krav Maga, did some Western boxing, and reality-based self-defense of several different flavors. And I've been an instructor in TCMA and Krav. So I've kind of been around the block with martial arts, but that being said, all of the stuff that I'm about to talk about comes from a place of humility. I'm making no claims that these techniques are the best or the most effective. These are what work for me. Everything that I've showed you, I've used in drill simulations and in a couple of cases, real life altercations. But these are what work for me. I wanted to give you some opportunities to add these to your repertoire if you're a martial arts practitioner. And if you're not, if you just are interested in some self-defense, these are some great tools to add to your tool bag to keep yourself safe. And since we are in confined spaces right now, elbows are great because they don't take up a lot of space. So if you want to do some shadow boxing in your apartment or your house, you can do them without breaking stuff. So I love the elbow. I love the elbow so much as a striking implement and a defensive implement. The first reason is that elbow strikes or elbows happen at the range of conflict. If you think about putting your arm all the way out, most people are not in conflicts at that range. When people are aggressive, they're getting up in your face. And what that means is that throwing a full length punch is too far. So you need a tool that is closer to hand, right? Something that handles that particular range. The elbow, when we think about striking power, we are concerned about force over surface area. If you think about your fist, right, it's kind of wide, right? There's a lot going on here. In traditional Kung Fu and leopard style, they use the leopard fist, which takes that same amount of force, right, that same amount of joint work, and applies it over a smaller surface area. Well, elbows do the same sort of thing, right? We have a much smaller surface area, so the penetrating power is pretty high. In fact, it's the highest for a striking implement above the waist. It doesn't have sensitive bones in there. I'm a piano player. I write code. I need my fingers to work, right? So I'm less concerned about my elbow having some small delicate bone broken than I am about my elbow. You can use the elbow on multiple angles and axes, as we'll see in the next slide. And because the elbow, as we put it up, protects ourselves, it is both defensive and offensive. And then for those of you who've ever seen Black Belt magazine, that's my best Black Belt magazine cover impression. So I would be greatly remiss in my martial arts instructor duties if I didn't start with stance. So what we're going to cover here, you can use whatever stance is useful to you, but we've got 70% of our weight on our front leg, 30% on our back. Our knees are bent. We're nice and comfortable, right? This isn't necessarily a traditional stance. This isn't a bow and arrow stance or whatever you want to call it. My weight is on the balls of my feet. My hands are up and relaxed, but ready to protect my face or my lower body. My chin is tucked, and a square stance, meaning that both of my shoulders are equal distance from my opponent, maximizes my weapon availability. So I'm not blading off, right? I'm not turning one of my shoulders one direction or another. Some people might say, especially if you've been in boxing, like, well, I know how to throw a hook. Why would I do an elbow? An elbow is, I think, a more effective tool than a hook. And I'm talking about proper hooks here, not haymakers. So if you look at, I'll get my pointer up. The first thing that I do in this animation is this kind of looping punch, right? That's no good. That is a haymaker. And what's really dangerous about that is that you don't have a lot of your skeletal structure reinforcing your strike. So it's a great way to break your fingers or your wrist. And you're not delivering a lot of force because there's not a lot behind it. A hook, right, is essentially a 90-degree bend in your arm, and you're using rotational force to deliver the strike. But again, we've got all those delicate fingers in there going toward the skull. So there's a lot of hard against hard going on in a hook strike. With an elbow, we can protect ourselves a little bit better at the same distance as a hook. So elbows can rotate around the vertical axis and the horizontal axis. And combining the two into a kind of angled strike is really, really powerful. So what I'm doing here are kind of the 6 stationary motions for elbows, right? We've got horizontals, the overhand, and then the verticals coming up and down. And important here is that the power, just like every strike, is coming from the waist. So pay close attention, especially if you're practicing these, to your waist movement, right? I am turning my waist and keeping my feet grounded, right? If it's a strike with the rear hand, my rear foot is pivoting. If it's a strike with the lead hand, then my lead foot is pivoting. It's almost like I'm crushing something out, right? Now, these are stationary, but there's another directional application of elbows, which is forward motion, right? I can charge, I can invade somebody else's space if I need to with the elbow while protecting myself. So this is the first move I wanted to share with you. This is the crash. So the idea here is that we are kind of intercepting maybe a haymaker or somebody else trying to come into us. Most commonly, people are going to try to grab you, right? So there's this outside armature that we're trying to get inside. So that first part, right, we're crashing in, we're using a forward motion to get inside. And notice that elbow, as it leads, is striking into the chest, maybe the solar plexus, depending on what we want to do. Once we're there, what's really important about this is that it's so unexpected. It breaks your opponent. I should have said the attacker's OODA loop: observe, orient, decide, act. Your attacker has that, right? They have decided that they want to hurt you. You can interrupt that flow by doing something surprising, like throw that elbow, right, into some squishy parts, right? There's a lot of stuff in here that's going to be painful if it's hit with a small point like an elbow. From there, you have the ability to take control of the situation. And what I'm doing there is I'm grabbing heads, I'm using a knee strike, and then I can finish up with a vertical elbow to the back. So it's a great move to just, and also notice that as I'm going in with a crash, I'm covering my head. So if there is another hook, it's not going to hit my head, it's forearm, which is exactly what I want. That should say move number 2. Sorry, I can't count. So this is the cross block and overhead, and this was inspired by 2 styles. One, Wing Chun, which is a style of Kung Fu from the South. The crane's wing in Wing Chun Bong Sao is meant to redirect a blow off to the side. 52 blocks, which is an American style, uses something called the skull and bones, which is very, very similar. So what we do with this block here is that we're taking a strike, we're kind of absorbing it and redirecting it off to the side. But then we're using that overhand to control the incoming limb. We're wrapping it, and then we're maybe pulling in, but then we are delivering the elbow over it so that we have the ability to respond and control at the same time. So we're taking care of our defense, and then because we can catch and control, right, we are delivering the strike. Okay, move actually number 3 then is the vagus combo. The vagus nerve runs from the brain, down the neck, around the heart, and the stomach. If any of you have ever felt really, really nauseous while you're working out, that's the vagus nerve. And it is a great target for knockouts. If you deliver enough penetrating force to the vagus nerve, your opponent will stop moving. And so if I'm coming to the inside of an opponent and I really need to neutralize the threat, that's something I want to try for. So what's going on here is that my lead hand is blocking an incoming strike as I, again, intercept and almost crash with my rear elbow. Because that lead hand was intercepting a strike, I'm on the inside, and I can drop my hand down onto the neck, attempting to strike the vagus nerve. And then kind of as a finisher, I'm using, because I'm dropping my weight, I can then spring back up with my rear elbow. So it's a nice move, and it feels good when you do it. Just as an exercise, it's a fun move to deliver. So those are the 3 moves that I wanted to share with you, kind of unconventional uses of the elbow that maybe you can mix into your own practice. Train hard, fight easy, right? We want to protect ourselves, right? Both, of course, physically and in a health sense. But if we're learning self-defense, we want to make sure that we're ready to use it when we have to. So, you want to think about these tools, figure out how they might work for you. I make no claim that these tools will work the same for you as they do for me. Everybody's kinesthetics are different. But it's something to practice with. I think of martial arts like music, right? So you start by learning the forms, you learn the drills, right? You're reciting other people's work. And then after time, you learn to improvise and create your own. And that's kind of where, I hope you can take this, is that you can add this to your repertoire and play around with it.